You're watching the Weiss channel. Today we're going to do confidence intervals for proportions. We've taken the margin of error before, but now we're going to actually find the confidence interval. For example, out of 160 voters, 96 respondents said they preferred candidate A. Determine a 95% confidence interval for the proportion of people who preferred candidate A to the nearest 1,000. So, we've got 160 voters, 96 respondents. That's 96 out of 160. If you divide that, you get 0.6. So if 0.6 is P, then in this formula here, where Z is 2 because 95% confidence interval, remember, is 2 standard deviations. Okay. So 1 minus P is going to be 1 minus 0.6, which is 0.4. And of course is going to be the 160. So N is 160. So we're going to do 2 times 0.6 times 0.4 divided by 160. That gives me 0.0774596 and so on. To the nearest 1,000, that's 0.077. So the confidence interval, all you have to do is take this 0.6 and go minus 0.077, which is 0.523, and 0.6 plus 0.077, which is 0.677. Okay, that's your confidence interval. With this number being kind of the middle, you go plus and minus this number that you calculated, 0.523, 0.677. Same thing here, but this time they give you P. You don't even have to calculate P. I forgot to put in here that we're rounding to the nearest 1/10%. Out of 195 residents, 20% said that they were in favor of the plan. Determine a 95% confidence interval for the percentage of people in favor of the plan. Okay, and we're going to do to the nearest 1/10%. Okay, so it says 20%. So that's your P, 20% or 0.2. 195 residents, that's your N, 195. Okay, we're going to use this formula again. So if 20% is your P, 0.2, then 0.8, 1 minus 0.2, 0.8 is your 1 minus P, and is your 195. So you multiply that out and you get 0.057289. You move the decimal 2 places and you get 5.7%. 5.7%. So you're going to take 20% and you're going to go minus 5.7 and 20% and go plus 5.7. You get 14.3%, 25.7%. If you're doing the Delta Math assignment, do not put the percent sign in there. You've been watching the Weiss channel.